So this is a recorded video for the MISS Lecture 17 on flammable liquids leading up to spray booths and a little bit about ventilation in flammable storage rooms. So Subpart H goes into hazardous materials. You can look at these on your own: compressed gases, acetylene, hydrogen, oxygen, nitrous oxide. What we want to get to is 106, which is flammable liquids and flammable and combustible liquids, but I believe it's just called flammable liquids now. 107, which is spray finishing, so that's going to be your spray booths. But on your own, you can look at 109. I think we may have referred to it before, but whenever you have a fork truck that's running on liquid petroleum, you would also want to reference 110, which is the storage and handling of liquefied petroleum gases. LP is liquid petroleum. And if you're working with either a pool or a refrigeration system, you may want to check out 111, which is storage and handling of anhydrous ammonia. Later in the semester, we may spend some time talking about process safety management, which is 119, and hazardous waste operations, and emergency response. That's also called HAZWOPER, and that's 120. If you happen to be going into a dipping and coating operations, that would be 122 to 126. So let's talk about flammable liquids. What you see on the screen here are several different flammable liquid containers, and they're all being stored in a flammable liquid storage cabinet. So the concern with flammable liquids is it's not really the liquid that burns, it's the vapor that's given off. And so there are certain liquids that have properties, chemical properties. You learned it in chemistry courses, in which they have higher vapor pressures, higher or they have lower flash points, which is when they can burn, or lower boiling points. Flash point and vapor pressure tend to be kind of similar, in which they vaporize. They move from a liquid to a gaseous state, and then if they have a whatever their lower explosive or lower flammability limit is, once it reaches that cloud of the vapor that's coming off the liquid, is capable of one, catching and then possibly sustaining a fire. And once a fire begins, once you light a cloud of vapor, it tends to heat any liquid that's nearby, therefore increasing its rate in which it vaporizes and sustains a severe fire. And as the heat goes up, it destroys things around it, consumes oxygen, mayhem. So the terms: flashpoint and boiling point to determine the classification of a flammable liquid. Now, they do talk about combustible liquids on here. That was an older term with before they changed 1910-106, but we'll get into the classifications later. So this is I believe this is the old system. We'll talk about the new system later, but again, you see here that it's based on flash point and boiling point. What's interesting though is I created a table. I downloaded a bunch of information about different chemicals, and I've got them listed over here on the left. And I've got this post on the D2L. I've got some 250, yeah, about 248 different flammable liquids, and what I graphed is their flash point versus their boiling point. And as you can see, it's a pretty dense line here. The lower is lower, the higher is higher, and so you don't have too much deviation other than right around that 100-degree point. That tended to be kind of a cutoff point in the slide presentation, as you can see right here. I'll try to get this back into presentation mode, but we'll get into that. So things like ethyl ether is class A or class 1A on this screen. I think everything has gone to 1, 2, and 3. And there's some combination we can talk about later. And this is all things you can also find on the NOSH Pocket Guide. We had talked about that when we talked about the health standards, when you really need a classification of the liquid itself. Gasoline is a class 2, I believe, so is methyl ethyl ketone, toluene. Class 3, I believe, would be xylene, turpentine, yes. I talked about lower explosive or lower flammability limits and upper flammability limits. And so once there's a concentration in the air, and they give it by a percent, this is called their flammable range. And as you can see, when there's too much, there's not enough oxygen to sustain down here at the lower. There's not enough of the actual vapor to catch and sustain. And so it's most flammable right in the middle of that range. And every flammable liquid has its own range, upper and lower. Another thing we need to do is when we recognize that a liquid could give off enough vapor to burn. We want to do several things to try to control that. One is we'd like to contain it, because if it's contained, then it doesn't get released, and then it's not being exposed to the environment, doesn't create as big of a hazard. But if it spills, so that's the other thing, we got to store it so it doesn't spill. We also want to control ignition sources, and that's a big part of 1910-106. And that is, we store it either in a well ventilated area, or when we're transferring it from a larger container to a smaller container for use, we're bonding and grounding the system. What that means is the containers should be metal so that we can connect wires between the large storage containers and a ground point, so there's like a metal bar that goes into the ground, and connect a line to the can we're transferring to. So there is no buildup of static electricity, which when it gives, and in the wintertime, when you build up static electricity, you get close to something metal, it discharges a spark. That spark could catch the vapor cloud due to the volatility of the liquid. Fire control, we also want to be able to, if a fire does start, we don't want too many combustible things around. We like to contain it. We also need sort of a suppression system. And so just through pure storage, handling, containment, ventilation, bonding, and grounding, that's how we try to limit the chance of the presence of flammable liquids at our work site to cause a major problem. And so spill containment should have been on here too, but I kind of mentioned that. So we want to control ignition sources. So whenever you have flammable liquids stored or being used, there should be a no smoking sign. I mean, that should be obvious, but we want to control all things that could possibly ignite a cloud. Should a cloud or a vapor cloud capable of sustaining a burn develop. But we want to try to limit that from happening, but we want to control the ignition sources as well. So this, I talked about static electricity. When liquid flows through a pipe or a line under certain conditions, it can build a static potential, and that static potential then would want to release into a ground. And so if you're filling a bucket or whatever, and the bucket's touching the ground, and it gets close enough to where the static potential is grown, a little arc can be created. And if you want to see what I'm talking about, you can go onto YouTube and search like static fire at a gas station. So somebody in the wintertime, when there's less vapor, water vapor in the air, when it's drier air, there's a greater chance for a static potential to develop. And so someone puts the nozzle in their car, and then they go back into their car. They're wearing a wool coat, and so that static charge builds up. They walk back over to take the nozzle out, and because there is vapor, flammable vapors coming out while you're filling your vehicle, that's just pressure. It's basically, as the liquid goes in, the air has to go somewhere, and that air contains the flammable vapor. You can have a static spark, and that can cause a fire. And people always freak out. They tend to make it worse than it is because they panic. Here's what I talked about for bonding and grounding. What you're doing is you're trying to create a balanced system so there is no static potential that would want to release. And so you bond the two metal containers, and then one of them needs to be to a ground. So again, it dissipates any static potential. So we could talk a little bit about ventilation. I'm going to show you how to calculate some ventilation stuff. There are some requirements under 1910-94 for spray booze. There's also some requirements under 1910-106 for flammable storage rooms. Okay, so we're getting into storage fundamentals. There's certain things we can do. It says you can check the safety data sheet. I prefer to check out the NIOSH Pocket Guide. It has better chemical information in it. We want to try to store it away, keep it away, a cabinet, its own container that's just one shift's use. That's all you can have outside of a storage area. So storage room, storing outdoors, storing in a tanker that's protected outdoors. What we want is, if there is a vapor release, that it's not in a place that could, become concentrated enough to exceed its lower flammability limit or lower explosive limit. I think we probably looked these things up. This looks like a table from 1910-106. I think it's table H, if I'm not mistaken, which it talks about based on the type of container, how much of a class flammable liquid can we use. And so this is the old system again, but the old system, I think it's A, or it's 1, it's 2, and it's 3. And I think 1A is the 1. I think 1B is the 2. I think 1C, class 2, and class 3 are all 3s. I think that's what it breaks down to. I looked it up once and it kind of fit like that. So storage of flammable and combustible liquids. Again, we just tend to call them combustible liquids now. We have an inside storage room, and I actually have a video that you're gonna want to watch after this, in which I toured. I did kind of a hazard audit of the paint room, the paint. I guess we could call it paint department on campus, and I kind of point out certain things. But you may want to check out 1910, 106, and 107 before you do, because I do point out certain things. And it talks about storage and access ways. Cool. Safety cans need to be metal. They need to fault close, so that's the spring loaded. You want to have a relief in the back that has a brass fitting for spark arrest, so that when you're pouring, air is coming in through the back, so it can pour out without splashing and glugging, which can cause spattering, and then you have more of a vapor cloud. The approved container cannot be more than 5 gallons, but again, it depends on what classification of flammable liquid. So those plastic cans that you can pick up really cheap from Menards and Home Depot cannot be used in the workplace. We just use those at home. So here it's got the flame arrestor screen on the port, but it can also be on the back side too. We just don't want a spark to get in there and light things. The storage cabinet, I provided some really cool videos for you. And also I found another video from a friend of mine who's a consultant. She talks about storage of flammable liquids too. So flammable liquid cabinets, and I do review the one that's on campus as well. It's got a maximum storage amount. This is under 106. It needs to have labeling. It needs a 3-point contact door. It needs to be completely enclosed, and you're only supposed to store certain flammable liquids in there. And so the other videos really do a good job. You should have suitable response, whether it's an automated fire suppression system, training workers who use flammable liquids or are painting. They should know how to use fire extinguishers and what size fire they can fight. When we're transferring liquids, depending on how much is there, it talks about using a closed piping system. So you want to contain it using safety cans, bonding, grounding, gravity instead of pumps, things like that. But when you put a pump in, the pump can fail and then things go all over the place. Self-closing faucet, you want that instead of having a what do they call that, a screw valve? Because if you have a screw valve or a ball valve, the person could leave it partly open. It could drip. When you have it spring-loaded, then it fails close, and that's what you want. Got some other points here. So look at you got a hand crank. You got everything bonded. You got it grounded, so that as the flammable liquid runs from the pump through the line into the can, any static potential is dissipated, and then there won't be a spark. So here's some other, the safety disposal can that isn't meant for transferring flammable liquids. It looks plastic to me. We've got the oily can, the self-closing lid. Those have to be changed after every shift. I actually have one of those in the video of the tour of the paint area as well. You look at this stuff here. I mean, again, we're kind of going back to, again, remembering the labeling of things, being smart with things. If you have a 55-gallon barrel, you better have a containment system. And flammable liquid storage rooms need to have a diked entry point. The door needs to be fail closed instead of just close when you close it. You need to have intrinsically safe electrical. Lots of things, and ventilation as well. And so there's a lot of things you can do to prevent either a hazardous vapor cloud from developing or from catching because of ignition sources. There's a National Electric Code standard that also gets into this. It's got these different types of class locations, but we really don't need to get into those. Another big issue that I'm not going to talk about is combustible dust. Here it talks about fibers and filings. Dust is kind of a national emphasis program for OSHA right now. So if you have a dust, whether it's an organic dust, and they tend to be a fibrous cellulose base, something like that, even some metal dust that under the right condition can, if an ignition source is present, what it does is because of the particles, when they burn, when just one burning is no big deal. You've seen something burn. But imagine that times a million, which a million little particles burn all at once, or in a cascading motion. It consumes oxygen, but also can create a percussion wave, which can damage other equipment, which can then promulgate a fire and hurt people. We don't have to get into hazardous this stuff here. I think we're just getting into. Okay, so I pretty much covered the flammable liquids, and I'd like to stop this, and we will pick this up in the next video. 15 minutes, not too bad.